All right, welcome everyone. In your careers, you're going to be the go-to experts on nutrition for your patients. So today, we're not just going to memorize a bunch of facts. No, we're building the core framework you'll use to understand vitamins for your entire career.
So let's kick things off with a little clinical puzzle, something that really gets to the core of what we're talking about today. The answer to this question isn't just some random fact for a test, It actually comes down to one single fundamental principle. And once you get that principle, I promise everything else about vitamins just clicks into place. We're going to uncover it today.
Okay, here's our game plan. We'll start with the basics, figure out that one big rule that splits them up. Compare the two groups, and this is the important part, we'll see how all of this actually works in the real world, in your future practice.
All right, let's dive right in. Section 1. Look, before we can even think about talking about things like deficiencies or supplements, we've got to get on the same page. We need to start with the absolute fundamentals. So what is a vitamin, really? What's the scientific definition?
Okay, so here's the classic textbook definition, and you'll see every single word here is important. They're essential, they're organic compounds, and here's the kicker. Our bodies generally can't make enough of them on their own. That means, plain and simple, we have to eat them to stay healthy.
But, biology loves its exceptions, right? And this rule has a couple of big ones you absolutely have to know for your exams and your practice. For instance, our skin can actually make vitamin D when it's exposed to sunlight. And our bodies can whip up some niacin, that's a B vitamin, from an amino acid called tryptophan. These aren't just fun facts, they're clinically super important.
Okay, moving on. This next part, this is probably the single most important concept we're going to cover today. Seriously. It's the one idea that explains everything else. How they're absorbed, where they're stored, even their risk for toxicity. If you get this one thing, the rest is easy.
And it all boils down to just one word: solubility. That's it. Does it dissolve in fat or does it dissolve in water? If you can answer that simple question, you can pretty much predict its entire life story in the body, how it gets in, where it hangs out, and how it gets out.
So with that in mind, let's put these two vitamin families side by side and see how they stack up. You're about to see just how powerful this one little concept of solubility is. It really does explain everything.
First up, we've got the fat-soluble vitamins. That's A, D, E, and K. Now, since they dissolve in fat, they kind of need fat to act as their taxi service to get into the body. They get absorbed with fats from our diet into the lymph system. And from there, they can get to our cells and do some really cool stuff, like acting almost like hormones, even influencing which genes get turned on or off.
And on the other side of the ring, you've got the water-soluble vitamins. This is vitamin C.